Hey, welcome back to another video tutorial on how to use the traffic software. Today we're going to look at Synchro. So here I am looking for Synchro and I found it. Click accept and Synchro will load up. So today we're going to actually be modeling the intersection of Columbia and Westmount in the region of Waterloo. This is what it should look like after it's done. You'll have a nice base map. You'll have all your roads drawn in. Yeah, you'll have all the traffic volumes and you'll have your signal timing. All done. Looking good. And I'll also be showing you how to make reports from Synchro, and I'll have everything you need for your assignment. So, in this brand new Synchro file, we're gonna first look into mapping our intersection, so actually selecting the map that we're gonna build off of. So under the Home tab, we have all these different tabs that you can go through in the top. It looks a lot like Microsoft Excel. But under Home tab, there's this mapping section on the top left corner. And we are going to click under mapping, select background. Select background. And under select backgrounds, you can see background file list, all this nice stuff. Go to Bing region list and click Bing region. And this is much easier to deal with than Vism because you can just look up the intersection that you want to model using Synchro. So Columbia, Westmount, Waterloo, Ontario. And look, it's the region Waterloo. I found it very easily. Yeah, so what you need to do now is essentially just zoom in into the area that you want to model, making sure to capture the full extent of the intersection. So please include essentially where the Wi-Fi detectors were when you did the data collection on the Thursday and the Friday. So that's what I'm doing. You can click select region up in the top left corner, and you'll have this cross arrow. Click, left click, and drag to the other end where you want to have your region, and it will highlight everything in orange. So you've selected your region. Now it's going to tell you to drop a pin to set your reference point. Because you're only modeling one intersection at this point, your reference point doesn't really matter because the reference point will allow you to enter real-world XY coordinates. That's not super important for this assignment. Maybe if you had more intersections to model using Synchro, you should do that because it'll give you a good frame of reference. But right now, you're all good. You can just set your reference point in the middle of the intersection. Yeah. Set it and forget it. Yeah, you can leave that at 0. That's fine. And now it downloads the Bing maps. And it will get you the map that you need to make a nice Synchro model. That was a very bad cutaway, but you know what? It's fine. Yeah. Another nice thing you should do is check your scenario properties, because then you can better document what you're doing. So I'm adding a description, Columbia Westmount tutorial, we collected data. Let's say this is the Thursday AM group. So that would be September 12th, 2019 in the morning. And put in your name as your analyst and all that nice stuff. Awesome. So now you have a nice background map to work off of. Here's metric. There's a metric option. It's kind of counterintuitive because if you click metric, it becomes imperial. But if you don't click metric, it stays metric. So don't touch that. But if you, for some reason, need to change to imperial, you know where it is. It's under Options tab in the Microsoft Excel knockoff ribbon. So yeah, we can start building our road network. Okay, we can draw the road network now. So you, in the upper left-hand corner, there is in mapping a tiny road. It's the first tiny road. It is the upper left-hand corner tiny road. And to draw the link, you click and you drag. You click where you want it to start and drag it to the side. So click to where you want it, drag it to where it ends. Make sure to have the intersection of the two links actually be where the intersection is because it makes your life way easier. And you got it. Oh, no, there we go. Oh, and click. No, not yet. There. And click and drag to make your intersection, so that the intersection of your two links is also where the intersection in real life is. There's a bit of a pause. Yay! Okay, and now you can just click around the links and right-click different sections of the links to add curvature, and you can click at, so yeah, you could add curvature, but let's say you want to actually move, kind of shuffle around the links themselves. You want it to end somewhere else. You click the very end of the link so that a highlighted circle goes around the end of the link, and you can move it. Right click, click move, and you can move where the link ends. Yeah. So now I'm gonna add the curvatures. Oh, that was just me showing you that you can pan the image by clicking the scroll wheel and dragging around. And if you want to zoom in and out, you can scroll in and out. Yep. So that's me clicking around, showing that you can add curvature. And that's me adding the curvature to the road. What a wild rodeo. So yeah. Add your curvature, make sure it matches up with real life as well as possible, because this may impact your modeling. Make it match up with the road geometry. Here's me just testing it out, playing around with it, trying to make it fit Westmount Road as well as possible, adding some curvature, playing around with it, you know. I know I want to move that up, but then my curvature gets weird, so I undo that. If anyone figures out a better way to do this, let me know. Comment down below if you can figure out a better way of modeling, because I would like to know as well. It'd be really nice. Yeah, so I'm just adding curvature, making it look nice, and matching up with the root geometry. So now that our road network is drawn very nicely, it matches the road geometry, we can add in our lanes and assign our lanes. So click the link near the node, and on the left hand side a blue box will show up, and this just shows you the different settings you can do. So right now, regardless of what shows up, you can change your different arrows and you can make it reflect real life. So right now I'm putting left turns, 2 throughs, and a dedicated right turn into my Synchro model. Dedicated right turn. And on the northbound, I click the link near the intersection for the northbound. I put in a left turn, and because northbound is actually one through lane and one shared lane, I look for the through arrow with another through arrow with a little thing going off to the right that indicates the through right lane. Yep. So I just do this for all my approaches. Well, I think I misclicked, but yeah, that should be the through arrow with the shared right turn. You will see that in the westbound. Left turn lane, through and through shared right turn. This is also where you can enter your traffic volumes by just double clicking the links near the node. And let's say for some reason your receiving lane, so your receiving lane has multiple lanes, more than 2, you can change it by going near the end of the link, as I did a couple seconds ago, and click it away from the intersection, and click it, and then you can add as many lanes as. So if we make the receiving lane massive, you click near the end of the link, and you can change the number of receiving lanes. So the westbound through on this west leg, 5 lanes, which is too big, but if for some reason you had 5 receiving lanes, you could, but let's just change it back to the 2. Yeah. So you have your nice intersection. You have all your turning movements. One thing to note here is in lane settings, stay in lane settings. You can change a bunch of different parameters and stuff. Like there's also volume settings where you can change different parameters, but in lane settings, you should go and look into storage length. So there's lane sharing, traffic volume, future volume, street name, link distance, link speeds. You should change your link speeds. Travel time, lane width. You should change your lane width, grade, area CBD, and storage length. So you should definitely check your storage length and update it such that it is correct. So to check your storage length, you go into Google Maps, you go into your intersection, and you essentially just measure the storage length for your left turns and your dedicated right turns, if there exists a dedicated right turns, how long those lanes are. So we saw in Google Maps it was around 70 something, 77 I think. Oh, 73. So right now, by clicking that, you've now made your storage length 73. Do that for the same for the rest of your intersection. Oh yeah, make sure that's a shared right turn. Yeah, so now you have a nice road geometry. You want to actually add in your traffic demands. And you do that by clicking your link. Oh, here's a very nice pro tip. If you go into any of those blue left-hand side boxes and double-click an empty box that just has a dash in it and double-click it, this network settings things will pop up. Like, it doesn't matter which blue box. As long as it's one of those blue boxes, dashed box, double-click it. You can change a bunch of things all at once. So what's important to change? Double click the dash box. One of the nice things you should change is lane width. Lane width, vehicle speed, and you can set it all the same for your entire intersection, like peak hour factor, phases, all that stuff, all this nice stuff. So lane width 3.5 according to the Region of Waterloo standards, and you can set it all. Set all. And now it might not show very much, but you have changed your lane width to 3.5. Your travel speed throughout the entire model is actually 60 kilometers an hour. Peak hour factor is something you actually calculated in your assignment. But the Region of Waterloo actually has a standard for traffic impact studies using Synchro that you can set the peak hour factor to just 1, and you can set all. But I would recommend you follow what you found in assignment 1 for your peak hour factor. And now, in lane settings, when the blue boxes show up, you can change your traffic volumes. And these aren't the right numbers, I'm just typing stuff in, so you can see how it works. Look, it shows up. Fantastic. Yeah, so we can now go into actually inputting our signal timing. So if you click the middle of your intersection, double click it, a yellow box will show up on the left called node settings. And you can change a bunch of different stuff. Node name, zone, coordinates. Control type is probably the most important thing right now that you can change. So there are different control types: pre-timed, actuated uncoordinated, semi-actuated coordinated, actuated coordinated, roundabout, signal, unsignalized. So because this intersection is signalized, you should choose one of the signalized ones, like pre-timed, actuated, or semi-actuated. What they are exactly is described in the tutorial document. So if you don't know which one to choose that. Don't choose roundabout, guys, unless like that's a design consideration, you know. But choose one of the signalized ones if you want to model real life. Once you're done that, in the top ribbon of home, you can click the signal head called timing settings, and you will get this nice thing. So click the node, timing settings, signal head, and it will allow you to enter the signal timings. Awesome. So you will enter the amber and the red time as usual. You were given the signal timing in assignment 2, so follow that. What is important is the splits. So you can see on here that you have the yellow time and the red time, you can enter that easily. But how do you enter the green time? One of the key concepts to remember is a split is the total amount of time for that phase. So if your left turn phase has 5 seconds of green time, 3 seconds of amber time, and 1 second of all red, your split is 5 plus 3 plus 1, 9. And that's what you would put in the split. But before you add your signal timings, what you should do is change the turn type that's underneath lane sharing, traffic volumes, and future volume, such that your left turns are permitted protected, or PMPT. So turn type PMPT for all your left turn lanes. If you have an advanced green arrow. So if you have your left turn advanced green arrow, PMPT, permitted protected. That means that you're telling Synchro that you want to give an actual signal timing to the left turns. Yay! Left turns. And then your right turn should remain as permissive, because what protected means is you have a specific light for the left turns. Permitted means they're allowed to go during the right turns if they have the space. And having it permitted protected means they have their own light, but also during the through phase, if they want to go through, they can if they have a gap and it's safe for them. Right turns are permitted. Left turns are protected permitted. Protected permitted. Right turns are permitted. Left turns are protected permitted. Okay, awesome. And now you can add your timings. Follow the signal timing card. So now I'm going to close this real fast to show you a Synchro model that I have made earlier that has a good signal timing phasing thing inside it. So I'm not sure if you noticed, but before, in the old model, the one that I just made, there were a lot more phases. I think each left turn lane had its own phase. Each through maybe had a shared phase, but that's not exactly efficient. So what I did here was, I started on the northbound, southbound left turns as my first phase. Underneath the lane sharing, traffic volume, future volume, turn type, you see these protected and permitted phases, and it's like 3-4, 3-4, 1-2, 1-2. I changed that. I hard-coded that in, and I set my left turn phase as my first phase, my northbound, southbound left turn phases as my phase 1, my northbound, southbound through as my phase 2, my eastbound, westbound lefts as my phase 3, and my eastbound, westbound as 4 through 4. This just makes it a lot more efficient. Rather than having one phase for each of the movements, I'm sharing the phases, and it looks a lot more clean. Then so this tells you essentially which phases have their own dedicated light. So I'm just assigning all my left turns an odd number and all my through movements an even number, and making sure that in the permitted phases underneath that, for every phase where vehicles are permitted to also turn, I allow them to do it. So, for example, my eastbound left and my eastbound right are permitted to turn during the through movement, which is the eastbound, westbound 4. Eastbound, westbound through, which is the 4 phase. And people are allowed to turn left and turn right if they have the space. So that's what that is. Make sure you do that, and it'll clean up everything very well. Yep. So you can hard code that in. I'm going to open up my old model that wasn't completed. And I'm going to show you exactly what I mean and actually hard code it to show you. So go into timing settings with the signal timing head, and everything's permitted, protected, or permitted as required. And I'm going to change the protected phases. So I want my eastbound, westbound throughs, northbound, southbound lefts to be 1. I'm just typing it in. My northbound, southbound throughs to be 2. And then I want to permit my southbound left and southbound right to go through in 2. And I do the same for the eastbound and the westbound lefts. It's a protected phase 3. And the through movements will be a protected phase 4. And my westbound will be permitted during the phase 4. So yeah, now everything is in the right phases. So 3, 4, 3, westbound through is 4, permit the westbound left on the 4. And now we have all our protected phases. Now, this is your baseline model. What you can do is change it up. Let's say you want to improve it. You can optimize your cycle length, or you can optimize your split. And you can do that on your left-hand side under node settings. You have 2 easy buttons, and it will optimize your cycle length and optimize your split. What I would recommend doing is saving first your baseline model, checking out the reports, and then optimizing to find your improvements. So you can optimize the intersection itself. Under the Optimize tab, you can do essentially what the buttons do. What is useful here is actually under Optimize Network. You can optimize your cycle length and your offsets. Well, you don't need to optimize your offsets in this assignment, but optimize cycle length. Make some saves, save your changes, and optimizing your cycle length for the network allows you, in the top ribbon there, you can find it in the Optimize ribbon. You can change a bunch of different settings when you optimize network cycle length. What's useful is to change manual. So what Synchro is doing right now is manually going through different intervals of cycle lengths and trying to see what happens when you do each one. And it will give you the outputs, or a summary of outputs that people find important when doing modeling. So you have your cycle lengths and all your stops and delays per vehicle, fuel consumption. What's important here is to realize that these are different measures of effectiveness. So let's say you don't really care about delays. You think delays are unimportant and people can't be late for work. But what you want to do is to minimize fuel consumed. You can go into fuel and select it. Let's say it's because you're an energy efficient person or your municipality has a more environmentally focused policy. You can choose different cycle lengths based off of what your goals are for your signal timing. And yeah, so you can manually select a cycle length depending on what measures of effectiveness you want to use. You will most likely be interested in delay. So you can just manually choose one, which I just did. Doesn't really matter. You should care though when you're actually doing the assignment. And yeah, so I've chosen a nice cycle length. And now we can go into making the actual report that people usually include at the end of their submissions to municipalities for traffic impact studies. And you can do that by going to the Reports tab at the top, clicking Intersection, and here you can actually click and choose what you want to make the report of. You can change the scope, so if you want to select the entire network or just individual intersections, you can click around and click what you actually want to make a report of. So report, intersection. Add cues if you want, depending on your assignment. And yeah, I would recommend changing print setup. You can select the data to include. You can choose your scope, so your entire network or just a signal intersection. For this assignment, it doesn't really matter. Does not really matter. You can choose whichever one works best for you. You can change your headings and graphics and stuff. So I would recommend doing this. Print setup, change from actually printing it out to print to PDF. Because then you will actually create a PDF first that you can include in your Word document at the end of your assignment. Click OK. You can print it out, or you can preview it before you actually want to print it out. And you can check out all your results. And I'll tell you the delay of the intersection, level of service, all that good stuff. Fantastic. Nice summary information. Yeah, so this is all you really need to do for Synchro. It's a lot easier than Vism. Test it out, and if you have any questions, let me know. Bye, until next time.